Hi guys, in today's session, I'll be going through the OSI model and also I'll tackle unit standard 14913. So, uh, we'll start with the OSI, which is the Open System Interconnection Model. And OSI stands for an Open System Interconnection. It's a reference model that describes how information from a software application in one computer moves through a physical medium to the software application in another computer. So we will look into, we'll highlight important terms in terms of the first statement. Let's highlight a software application. We'll highlight in red and also moves through one computer. That's important also. A physical medium, software application also, and another computer. These are important aspects. So let's draw these these items. So we have one computer. In this instance, we will assume this is a computer. This is a desktop computer, and within that desktop we have a software. In this instance, we will use an Outlook. So we've got an Outlook, which is an email software. And also we have this will be our physical medium, which in this instance is our cablings. It's a medium which will allow data to travel through from one node, cabling, Ethernet. We've got Ethernet, which we have coaxial cables, coaxial cable, STP, which is UDP, shielded twisted pair, and unshielded twisted pair. We've got fiber, and so forth. And also we have our this is our desktop, and we've got our software, which is Outlook. Okay, and the layers in terms of what we have, we've got we have we have our, which is our application layer, presentation layer, session layer, we have transport layer, and we've got network layer, data link, and lastly we've got physical. We will, in descending order from top to down, that's how we accordingly to how we name the session layer, we name them according from top to down. We start with the application layer, we end with the physical layer. So we have a situation where in this instance we're trying to explain, I'm trying to go about in terms of explaining the application layer. So I've drawn out the interpretation in terms of explaining the OSI model, which in this case is a model that describes how information from a software application in one computer moves through a physical medium to the software application in another computer. So as you can see, we've got a software application moving from one computer to another. So we'll say this is a sender and we have a receiver. So we'll say this is KP, which is Gabelo, and this is David. So David will be sending information using Outlook as a software application from one computer node to another to Gabelo. So OSI consists of 7 layers, as I've mentioned. We've got about 7 layers: application, physical application, presentation, session, transport, networking, data link, and physical. Those are 7 layers, and each layer performs a particular network function. The OSI model is useful for troubleshooting network problems. Let's highlight that. Troubleshooting network problems. And whether it's one person who can't get their laptop on the internet or a website being down for thousands of users, the OSI can help. The OSI, let's highlight this, can help to break down the problem and isolate the source of the trouble. So let's look at the first. On slide 34, I've extracted an image which illustrates the OSI in detail to say the first 3, which is the the application, presentation, and session layer, depicts the software layers, and your network layer, data link layer, and physical layer, which depicts the hardware layers. This is more of your routers and switches. So on this 3, the first one, the first 3, we will it depicts the software layers. In this instance, in the example that I've provided, this is more of the 3 layers, which we will go in details by explaining what happens in terms of the process for sending a packet from one computer to another. Let's look at slide 35. The application layer, which is the 7th layer. This is the only layer that directly interacts with data from the user. Software applications, let's highlight that. Software applications, like computer application that uses the internet, like your web browser. Which are those web browsers we're talking about? Your Google Chrome, Firefox, Edge, which you are currently using, Internet Explorer, it's outdated, and email clients in the example that I've provided. Email clients, we've got your Gmail, Yahoo, and Outlook. Rely on the application layer to initiate communication. So we want to initiate communication. So in this instance, we find that David wants to send an email to Gabelo. So the most important things for application layer is that it is responsible for protocols and data manipulation. That's the most important aspect for application layer. So in terms of the protocols, it's the channels in terms of which application that I've highlighted. Like for instance, for computer applications which uses the internet, like your web browser, they have a certain protocol that they use for in order for them to communicate. For example, like let me just extract the Outlook example. For instance, Outlook have certain protocols that they use in order for it to initiate communication. So for Outlook to initiate communication, it uses port 25 for sending information. I just want to be precise because I think it was one of the good days I've shared a WhatsApp image on the group where it illustrates all the protocols for your email notification. And yeah, so let's use, yes. So for port 25, Outlook, it's for sending. So this, it's for sending. It uses this port 25 to send packet data. So let's say, for instance, you want to send an email which with an attachment of maybe a report. So you want to send, we assume this is the packet. A packet, it's an information which consists of attachment. It's a report. So it's your Excel document. This is an Excel document. It's a packet. So you want to send, David wants to send this attachment to Kabelo. So for it to initiate communication, David, at the back in terms of the application, its purpose is to use the port 25 for sending in this packet. So now remember that this is responsible for protocols. So this is part of the protocols that it will use. The protocols, and also manipulation of data. Manipulation of data. So as it sends this packet through the physical medium that we use in terms of the Ethernet cabling, in terms of receiving, Kabelo will receive this packet with a port of 995. Let's assume 995. So in terms of receiving, Kabelo will use this port. This is receiving. In terms of receiving, it will use protocol in terms of receiving packet from Kabelo, which is David. Sorry, man. David used the port 25 for sending in the packet, and Kabelo from the other side will receive this packet using the port 995. So in terms of the data manipulation, it's where data is being manipulated. Remember that data, even if this is a packet, the computer only understands zeros and one, numbers only. So this packet needs to be converted into zeros and one. So you may find that in terms of this packet might, maybe let's say this might, the size of this packet is about 3 MB. So converting this into zeros and one, it could be about 0 1 0 1 1 1 1 0 1 1. We're just hypothetically speaking in terms of manipulating data. So this might be the data package for this Excel packet. So it manipulates this data in terms of a way, in terms of computer language, which it can interpret what's the package for. So it will send this package data. We'll assume it's this Excel report, and it will send through the medium. And in receiving, Outlook will use this port in terms of receiving. So let's say, for instance, Gabelo received this attachment and wants to send a response to say, I've received your the attachment and thank you, thank you for sharing the report. Gabelo will use port 25 to share the exactly same report, and David will use port 995 in terms of receiving. So this is the part of communication that happens in terms of application layer. So let's move on to our slide in slide 35. So the application layer is used by end user software such as web browsers, and it provides protocols that allow software to send and receive information and present meaningful data to users. So remember, as I've said, in terms of the data, it will convert. Computers only understands uh, 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 the readable language that computer understands. It's in a form of zeros and one. So that's the form in terms of communication. So in for us humans or end users, if I may put it that way, we only understand alphanumeric type of data, where we actually see tangible Excel document that you have attached. So let's say, for instance, if the application could not manipulate the data by not converting it from this part to an alphanumeric. Remember that the application layer, in terms of the computers, they use this in terms of sending and receiving. So in for us to actually see the document or actually see the packet, it manipulates it to the form in order for us to understand. So let's say, for instance, it does not have that option where it manipulates, it only share the way it is. So we will only have to receive our package in this kind of format, and it would have been difficult for us to interpret. It would have been difficult for us to interpret the data. So moving right along in terms of the PowerPoint presentation, the application is responsible for the protocols and data manipulation that the software relies on to present meaningful data to the users. So the application protocols includes SMTP, which is the Simple Mail Transfer Protocol. So this Simple Mail is a protocol used by mail. It's one of the protocols that enables communication. So for you to have communication in terms of email, it has to use that protocol, the SMTP. It's the SMTP. For you to have this communication, it has to enable it. For you to enable communication, you need to use SMTP. And we also have, under SMTP, we also have post office protocol, which is the version 3, and we also have IMAP protocol. So these protocols differ depending on, they have their exact numbers that they use in terms of enabling communication. So these are what we refer to in terms of enabling communication. So moving on to slide 35. Also, we have a file transfer protocol, a post office protocol, and a domain name server. So these are just protocols that the application use in order for it to enable communication. Like, let's say, for instance, you want to log into to Google. So Chrome, for instance, let me be precise. Let's say you want to access Chrome, and Chrome, it's just a server on the cloud. And for you to enable communication, you have to use a protocol which is 80, which is port 80, or 443. There's a difference between using these two. So for in order for you to use port 80, this it's not secured, meaning that data is not being encrypted. And 443 is secured, which is HTTPS. So it's hypertext textile protocol, which is secure. So this port is used whenever on the internet. Let's say, for instance, you have your PayPal, and in your PayPal you normally pay accounts on the internet. So it will initiate communication using this port in order for you to encrypt data, since now the data that you'll be sending over the internet will have attached your IDs, your password, and so forth. So in this instance, this port is secured. So this, it initiates communication whenever you want to access your Chrome or any application which is on the internet. So for your Outlook or for your Gmail, it uses its own protocol, which is your SMTP, your POP3, your IMAP protocols that enables communication using email. So those are just your elements that you need to adhere to in terms of initiating communication on the internet. So on the slide, this is just a depiction, an image that I've attached in terms of going through all these. For instance, like let's say you wanna transfer important documents on the internet. There's a protocol that it uses, the file transfer protocol. You can use this protocol for you to share files on the internet, same as I've explained in terms of the HTTP and the HTTPS, and so forth. So let's move on to slide 37, which is the presentation layer. So the presentation layer is responsible for translation, encryption, and compression of data. So the two communication devices communicating may be using different encoding methods. So layer 6 is responsible for translating incoming data into a syntax that the application layer of the receiving data can understand. So if the devices are communicating over an encrypted connection, layer 6 is responsible for adding the encryption on the sender, and as well as decoding the encryption on the receiver's end, so that it can present the application layer with encrypted readable data. So the presentation layer is also responsible for compressing data it received from the application layer before delivering it to layer 5. This helps improve the speed and efficiency of communication by minimizing the amount of data that will be transferred. So moving on to the example that I've provided in terms of translation. So let's go back in terms of translating. Let's say, for instance, you're trying to access your bank, Absa. You're using Absa as your bank provider, Absa as your bank provider, and you want to access your account. You use protocols of initiating communication. You will use 443. So presentation is responsible in terms for translating. So the data that you send comes, you're sending a packet, maybe to say I want to access Absa Bank. So that packet presentation will be responsible in terms of formatting that packet in terms of zeros and one, and encrypting that packet. So it will format that packet in terms of zeros and one, send it to Absa, and Absa will share once again using the port 443 to say you want to access your account on the internet, and it will provide authentication where you will insert your details, where you will insert your details. So in this instance, when you share data and where it pops up on your computer to include your password and your login credential. Once that packet sends it back to the APSA, it will encrypt and compress that data. Remember that with the example that I've provided, it will depend in terms of the size of the packet that you are sending. So let's say, for instance, in terms of now, since you are attaching your password credentials, which includes your password, and yeah, it will include only your password. So we'll assume that the size of that packet is 5 MB. So in terms of the speed for you, for the packet to be shared, the presentation layer will play its role by compressing this data for you, in order for you to share that packet successfully and in a certain speed, so that APSA can receive that packet. So that's the dynamics in terms of presentation layer. It's responsible for encryption, which in this instance it will encrypt the data that you send from your PC. It will compress it, but it will translate the data in terms of the readable format that computers do understand, encrypt the data by adding security features on the packet, and also compress the data in order for this the packet to be shared on the internet. So it's translation and compression. So that's the presentation layer duties in terms of sharing data. So going back to the example that I provided with David and Kabelo. So in this instance, the packet that we have, we've got 3 MB packet, and now it has to translate the data in terms of zeros and one, and also encrypt the data, and after encryption, in terms of the process, in terms of encryption, it'll add alphanumeric text in terms of the on the packet itself, so that whenever there is hackers on the internet trying to sniff the packet, they can only see text that are not readable. So that's where encryption plays in terms of encrypting the packet. And on Kabelo's side, the packet will be decrypted by the presentation layer. It will decrypt the packet and be able to open it, and in the form of an Excel report that you have attached. So let's move on to slide 38. This is just a representation of what the presentation layer is. So slide 39 is a session layer. The session layer creates communication channels called sessions between devices. So this layer is responsible for establish of connection, maintenance of sessions, authentication, and also ensure security. So this session can also set checkpoints during a data transfer. If the session is interrupted, devices can resume data transfer from the last checkpoint. So in this instance, the basic the basic term or responsibility for the session layer is that it also deals with authorization and authentication and session management. So let's say, for instance, on the example that I've provided, we have shared, you have sent a packet, and this packet is an attachment, an Excel attachment of 3 MB size, and then that packet is being dissected into checksum. So we will name this checksum 1, 2, and 3. Let's say, for instance, you're trying to share the packet, and now the packet that you need to share will, so it is responsible in terms of establishing communication between the two nodes, and also maintaining. So this will assume this is the packet. These are your checksum. You've got 1, 2, and 3. So let's say, for instance, you the packet it sends 2 checksum to Gabelo. So in terms of maintenance, in terms of maintaining the data, it has to maintain the number of checksum that it has. So if, let's say, it has 3 checksum, it has to send the 3 checksum, which is the package of the data. So if, for instance, it only sends 2 checksum, the session layer is responsible in terms of maintaining this packet by having, as I've said, if the session is interrupted, devices can resume data transfer from the last checkpoint. So the last checkpoint, which is this, the last checkpoint, it will redo the process again and send the 3 packets that you have on repeat the process again in order for it to have these this packet as a whole. So that's the session layer is responsible for in terms of making sure in terms of the maintenance, establishing connections, and also synchronizing data, the terminal session between the end user application. So as you can see, this is one of the example that I've extracted where you're trying to access a client server application on the internet, and it requires authentication, authorization, and session management, which involves the process of the checksum, where if data is interrupted, it will repeat the session again, being able to manage whether the type of data that you have shared. So in this instance, we've got the text. It's just one. Let's say it's just one packet, but in the form of text and image. So in this instance, it may happen that you find that an image has been shared, but not only the text. So session management will always make sure in terms of manages the package that everything has been shared. So it will do the process again in terms of sending out this two packets, so that you'll be able to have on your screen an authentication pop up where I'm just hypothetically speaking, towards its back it might have maybe a layout of an image of an organization, and text where it requires you to insert your credentials. So that is the process in terms of the session layer. Moving on to slide 41, we've got the transport layer. So the transport layer is responsible for end-to-end communication between the two devices. This includes taking data from the session layer and breaking it up into chunks called segments before sending it to layer 3. So the transport layer on the receiving device is responsible for reassembling the segment into data the session layer can consume. This transport layer is also responsible for flow control and error control. Flow control determines the optimal speed of transmission to ensure that a sender with a fast connection does not overwhelm a receiver with a slow connection. The transport layer performs error control on the receiving end by ensuring that the data received is complete and requesting a transmission if it isn't. So let's check in terms of transport layer. It dissects or cut uh, breaking it up into chunks. So it breaks up the data into chunks. So let's say, for instance, we've got this data which we have an Excel report. So it will break up this packet in terms of packets. So we'll assume this, it has breaking up into 3 packets, and into they call it segments. Sorry, they call it segments. So it will break up this packet into segments. So this will be segment 1, segment 2, and segment 3. So these, and also it's responsible for flow control and error control. So flow control is responsible in terms of this optimal speed of transmission to ensure that a sender with a fast connection doesn't overwhelm a receiver with a slow connection. Let's say, for instance, David is sending an email, this packet, to Gabelo, and Gabelo now uses, he has changed his device. Now he's using a phone, a cell phone, to retrieve his emails and send emails over the phone. So we'll assume, in terms of the speed of the this laptop or desktop, it uses about 100 MB, and a phone uses about 15 MB in terms of the speed. So now the packets that is being sent, so the process in terms of data being shared, the speed, the optimal speed. Obviously, the computer uses a high optimal speed, and then a cell phone uses a low optimal speed. So flow control is responsible in terms of, slowing down the speed in terms of, from the point of perspective of a phone. So if data is being shared at about 100 megabits per second, obviously the phone cannot be able to receive or being able to initiate communication in that type of speed. So error control will make sure, in terms of lowering down the speed of the laptop to the standard of the phone, which is 15 MB. So the laptop will share data in terms of the optimal speed of 15 MB, so that the phone can be able to receive that data. Similarly, if, let's say, maybe the laptop share about 5 MB in terms of optimal speed, the phone, in terms of the flow control, its duty will make sure that it tells the computer to increase the speed to a level of the phone, which will be 15 MB. Okay, what was okay, yeah. Sharing data, flow control will its duty will make sure that the speed, optimal speed, is in the speed of the cell phone. If the computer share has an optimal speed of a high optimal speed, it will lower its speed according to the speed of a phone that it can receive the packet. So moving on to uh, slide 42, is just a representation in terms of the segment, in terms of how it's being divided into segments. A packet is divided into segments. So we've got the sequence. The sequence is the number. It could be 1. We can name the sequence in terms of numbers, and the port is your protocol in terms of the data, where you are initializing or initiating communication on the internet, whether you are using an email, which will be port 25, for instance. I'm just making an example. So this is how a segment is being dissected. So moving on to oh yes, also we have then error control. So the error control on receiving end, by it ensures that the data received is complete. Let's say for instance, similar like the session layer, you find that you have two segments being shared. So error control will make sure that the at the first initiative of communication between two computers, the agreement was you guys will share, you'll send me 4 packets and I've only received 2 packets. So error control will make sure that the data is complete, and if it's corrupted, it will request a retransmission in terms of resending these packets again, so that the data is complete. So those are the two fundamental things that you should understand in terms of flow control and error control under transport layer. So moving on to the session layer, the network layer, it's layer 3. The network layer is responsible for facilitating data between two different networks. So now we're moving on to the hardware. It's responsible for facilitating data between two different networks. If two devices communicating are on the same network, then the network layer is unnecessary. The network layer breaks up segments from the transport layer into smaller units called packets on the sender's device and reassemble these packets on the receiving device. So the network layer also finds the best physical path for data to reach its destination. Um, Best physical path for data to reach its destination, which is routing. This term is known as routing. So routing is the selection of the shortest path to transmit packet from one route to another. So now we're dealing with another segment, another part in terms of the 3 layers. So layer 3, 2, and 1. This is more of the physical layer. So on, let's, so for instance, let's assume that you're using, this is the router, and that is a router, and that is a router. So this is your LAN 1, and this is your LAN 3. Let me even, this is your WAN, not even LAN. This is your WAN. By LAN I may, this is your LAN. So this is your LAN 3. So let's assume in this network 1, you're trying to communicate with one of, this is a switch, one of the devices in your LAN is trying to communicate with this network 3 device. So routing is responsible in terms of the transferring packet from the shortest path. So your packet will hop from one, obviously it will hop from a switch to a router up until it reaches to its destination. So routing is responsible from the shortest path, from moving from one network to another. So let's say maybe for instance, you are from Johannesburg and we have a office at Cape Town. So logically, so your data will hop on from one network to another up until it reaches to your uh your office in Cape Town. So that's the logic in terms of data routing. It refers to. So if we can check on network layer, the important things that we need to know is that it facilitates data transfer between two different networks as I've depicted. So if we have network 1 and network 2, so it facilitates in terms of data being transferred from one network to another. So that's the responsibility of the network layer. It makes sure in terms of network packets is being shared, the packet that it has received from the transport layer is being shared from one network to another. So that's its responsibility. And also those packets, those layer breaks up the segments from the layer into smaller units, which is packets. And on the sender's device, it reassembles these packets onto the receiving device. So once it dissects the segments, it breaks them into packets, and on the receivers and it reassembles these packets. So let's assume these are three segments, and the transport layer will disassemble these in terms into packets, and can be 4 packets. They haven't specified the number. It can be 4 packets, and it will share. We'll assume that this is one, but inside this there are 4 packets, so it will send this on to another network, and on the receiver's side it will just reassemble it in terms of one packet. So also, yeah, this is what I've explained in terms of the physical part for data to reach its destination, and also it will find the shortest path to transmit the packet from the number of routers which is available. Moving on to data link layer, the data link layer is very similar to the network layer, except the data link layer facilitates data between two devices on the same network. So since we on network 1, we've got 2 switches. Let's assume we've got 3 switches. These are your switches, switch, and we have workstations. So this is the same network 1, and now a data link layer is responsible in terms of making sure that it facilitates data on the same network. So this is the same network. This is the same network. This is network 1. This is network 2, which has its own switches and nodes and so forth. So the data link layer, it's responsible in terms of facilitating data on the same network. The network layer is responsible in terms of facilitating data from different networks, data link within the same network. And the data link takes the packets from the network layer and breaks them into smaller pieces called frames. Like the network layer, the data link is also responsible for the flow control and the error control in inter-network communication. The transport layer only does the flow control and error control for inter-network communication. So data link is divided into 2 sub-layers, which is the logical link control, which identifies the network protocols. In this instance, the network protocols, we're talking about IP and TCP, and performs error checking and synchronizes frames and media access control, which is your MAC addresses, to connect devices and define permission to transmit and receive data. Remember on the previous video that I've shared, I've explained in terms of the only way for you to be joined into the network your devices should be assigned your IP addresses. So dot dot one, so this will be 8 dot z 8 dot let's say 8.1, and this is 8.2, this is 8.2. And also we've got the IP, the PC's MAC address. The PC MAC address will be, it's in alphanumeric, can be A, B, E, 1 1 3 4 5. I'm just hypothetically speaking, this can be the MAC address. So for data link layer, it has two sub layers, which is your logical link, which performs network protocols. It has to check whether the initialization of communication, which protocols it's using. We've got your IP address, which is an assignment of assigning of your workstation, and also the TCP, and also your MAC addresses, which is assigned on the PC. So that's the only communication in terms of, being able to be recognized within the network. Moving on to the last layer, we've got the physical layer. So the physical layer is responsible for the physical cabling or the wireless connection between the work nodes. It identifies the connector, the electrical cable or wireless technology connecting the devices, and responsible for transmission of the raw data, which is simply a series of zeros and one, while taking care of the bit rate control. So as I've illustrated on the last example, in terms of having David and Gabelo having your physical medium, and we've got our Ethernet medium, our cablings, which is your Ethernet, fiber, STP and UTP, and so forth. So physical layer is responsible for that in terms of your cables, and between your network nodes refers to your switches and your routers. So that's it in terms of the OSI model. So I would like us to go through the unit standard 14913. So 14943, the purpose for this unit standard is to explain the principles of computer networks. The outcome is you at the end of this session, you'll be able to explain the principle of computer networks. It consists of 5 credits. It's in the field of information technology and computer science. So at the end, you need to be able to to provide fundamental knowledge of data communication and networking. You need to describe data communication, being able to demonstrate knowledge of main features of LAN and main features of WAN. So those are the purposes in terms of this unit standard. So in terms of session 1, describing the data communication. Data communication refers to exchange of data between a source and a receiver. We have done that with an example of David and Gabelo sharing information from one computer using a software, and an app-based software, which is, in this instant, it was your Outlook, and sharing data from one computer to another, and they use protocols. For sending it's 25, for receiving it's 995. So whenever they have to send, they need to use port 25, and for receiving it's 995, and for Gabriel also to send, he needs to use port 25. So those are the communication channels when you that it uses in terms of data communication. So we have done this, and the components of data communication, the message itself, it is informational or data to be communicated. It consists of text, numbers, pictures, sound, video, and any combination of these. So as I've provided earlier, that it can be an attachment of your Excel, and so forth. The sender we have done in terms of it is the device or computer that generates and sends the message. Similar to the receiver, it is the device or computer that receives the message. The medium is the channel or physical path through which the message is carried from the sender to the receiver. The protocol, it is a set of rules that govern communication between the devices. So how they went about in terms of explaining data communication, they have chosen their methodology. So with the methodology that I've used was introducing to you the OSI model in order for us to diagnose problems. So let's say for instance we have an issue in terms of uh, a user Kabelo, for instance, can share can only share a packet, let's say can only share send email to David, but David cannot receive the email. So in that instance we can diagnose in terms of what could be the problem. So we can test on our side to say, okay, if David can send a packet or a message or an email to Gabelo, and Gabelo cannot receive the email but can only send. So the problem is within configuring your process. It can be that you can test by actually taking troubleshooting steps to test if maybe the ports that you are using, change them, use other ports which are encrypted or not encrypted. You know, those are your troubleshooting steps that you can go about in terms of solving the problem. So also we've got the protocol performs in terms of the following functions. We have done data sequencing, data routing, the flow control and error control, the precedence and the order of transmission. We have done all these protocol in terms of dissecting the OSI from the 7 layers. Also looking at the description in terms of between differentiating between a LAN and a WAN. As you know guys, I think I've explained with this example. So a LAN is it's your local area network. So this is our local area network, and when it's your wide area network, like for instance having two routers or two LANs which are joined together. So that is more of your WAN. So this is the difference between in illustration. The simplest way to explain this is having a network within a geographical area, and when is more when you have two more LAN which are connected makes a. Okay, let's move on to session 2, demonstrating knowledge of main features of LAN. We know what a LAN is, the protocol, the architecture. Let's move in terms of the topology. The topology. So let's go to slide 50, a topology. So a network topology describes the physical and the logical relationship of nodes in a network. So in the network that we have, that you guys managed to do, let's remember on Visio you guys managed to draw a topology. So you had your LAN, you had your switch, and inside your switch you had your devices. So we will refer this as a star topology because of everything is connected to a switch. And also you had a router connected to it. So you had your 8 computers or 12 computers, including your cell phones, your server, and so forth. So this we refer to it as a star topology because of all your nodes are connected to your switch. So the disadvantage of using a star switch, for instance, if this switch goes down, every nodes will go down. Hence why on our planning, our brainstorming session, we have had we will include a data center where we will have our backup switches, where if the switch goes down, we now know that we will have our backup switch. So that's the simplest term to define a topology. Topology is just a the physical and the logical relationship of nodes in a network. So we have what we call a hybrid. A hybrid is when we have two or more topology that are in one logical sense. Like for instance, we have our switch and we have our router, and we also have our backup router also. So in this instance, we may refer this as a bus combined with a star topology. So we call this a hybrid because of it consists of two or more topologies. So moving on to your learner guide, let's start with a bus network. A bus network is made up of a cable called a bus that is shared by all workstations or network nodes. So all the nodes receive transmitted data, but the node into which they are addressed only accepts the data. Bus are easily and cheaply installed. The example is an Ethernet, which is the most popular. And we have a ring. A ring is where workstations are connected in a ring pattern. Signals in the ring are sent in one direction from the source node around the ring from a node. So these are just your Ethernet communication. So Ethernet configurations that you will use within your network. So data in terms of how it travels, which is your signals that move within your cables, will travel right around. So in basic simple, if let's say this is your server and your server tries to your client which wants to communicate to this to the client, to the server, obviously everyone within your network will receive that packet, meaning the packet everyone will receive up until it reaches uh, the the server. Unlike with a star, if let's say maybe for instance maybe this laptop wants to access certain files on the server, the communication will go through from the switch, and the switch will locate that packet to the server. So communication will happen between these two servers, compared to a ring where everything in a ring, everyone will receive the packet. So the disadvantages of a ring is that if one workstation doesn't work, it affects all the workstations. With a star, if one workstation doesn't work, everything continue as normal. But the main one is the switch. So if the switch dies, everything within that LAN dies. So hence why in our brainstorming session we designed that we want to have a backup switch. So let's say for instance this switch dies, then we have a backup switch which will carry on with the work. So a start network is where workstation is connected to a central workstation called a network server or a switch or a router. So the cable is not shared in a star network. So if the server ceases to function, it can cause total loss of communication to the entire network. If any one workstation is not working properly, it will not affect any workstation. So this is more of your advantages and your disadvantages. And going into the advantages of LANs, hardware such as printers can be shared, so individual workstations do not need their own printer. When they print, the data is stored in a queue on a server. The data is then passed to the printer. So let's go back to our so let's assume that this is our printer, and these users want to print. So they will send a package to the printer to say I want to print the Excel report. This user wants to print an Adobe PDF document, and this user would want to send a Word document. So these packages will be queued from the printer. In terms of its dashboard, it has a dashboard where you guys, when you send packets, it will queue your packets in terms of what it receives within the network. So the good thing is that all of your documents will be printed, but the disadvantage of it might be that if, let's say for instance, there's a paper jam on the printer, so now you cannot be able to print out, so your packets will be queued. So in order for you to fix this by releasing these packets, you have to fix the issue in terms of the paper jam. So once you release once you fix the issue by releasing removing the paper jam, you need to release these packets in order for you to print out the documents. So it will just in ascending form queue those packets for computer 1, computer 2, according to its IP addresses. And once the paper jam is fixed, you can just release these job they call it the job, I think the job, it's the job something. I even forgot the naming, but it's job something. So these job they release it, so in order for you to print out these documents. So that's how it works in terms of printing out document from your star topology or your LAN. Software can be shared. Software packages are stored on the server and downloaded to workstations as requested. Simple, like for instance, maybe you like the similar situation that you guys had in terms of your desktops. It had your OS that you have consisted of your Office, which was 2016, 2016, and the packages that you had within it was your Excel, uh, your Word document, a PowerPoint, and database. So how they went about in terms of installing that was within your Microsoft Cloud. They took the package of this 2016, install it to on the network, install it to about 100 devices. So we assume that this package is in a cloud. It's easier for us to locate these. We just are going to release a certain package for these laptops. Let's say maybe for instance, we'll have a package which will install about 200 desktops, install this Office. So when you get to a network, your LAN will take this package, save it on the server. Okay, this is our server. Save it on our server and share within the network. So this will just share this and install it to, let's assume that we've got about 200 workstations in our LAN. So we'll just install this package to the server and distribute it accordingly to all the workstation within our LAN. So our LAN will have this package within it. So that's the easiest way in order for you to share software on the LAN. So data can be shared. Central backup, where we have our backup server. So the server will have its services. It will back up data. It will have certain features within it, your AD, Active Directory, and it will have backup. So we will dissect our server in terms of the features that we want it to have within our network. uh, and it is possible to set up a local intranet such as that. Okay, an intranet is where we have our own applications that we have in-house. So our server can also have our internet where applications where users use a certain software, let's say maybe for instance the portal intranet. So the portal is more similar like our intranet. So we have our portal where we'll access. So our portal will be our intranet where we access study material, submit assessment, formative and summative, check when are we writing exams and so forth. So this will be saved on the server, so we anyone within this network can access it. And also people from outside, like from, let's assume, network 3 can access this intranet, but they will have to have authentication, uh, correct authentication. They will have to have credentials in terms for them to authenticate from this server to access the portal. So if they don't have the credentials for them to access, the system won't allow them to enter the portal. So the portal is more for our intranet. And also we have the disadvantage in printing can be slow, as I've provided that. Let's say for instance 3 workstation wants to print and we've got a paper jam, and logging on in terms of the jobs that that these desktop have shared, it can take about 10 minutes for it to be fixed. So even if there's no paper jam, for you to share, depending on the flow of network in your environment, can also affect in terms of the slowness. If maybe your switches are not configured to the best practice, that can also affect in terms of network being slow. So issues can arise like your paper jam where you're trying to print and uh, your packet has been queued. You have to fix the paper jam before, in order for you to print. So those are the examples that the disadvantages for printers being slow. um these are the ones you can just look at. It's something that it's items that I've covered. In terms of data is shared, is greater need for security. Users of the network have to have authentication. I've covered most of the things I've covered. And the types of LAN media, this is more of your, you know, the cabling, the Ethernet cabling that you need within your LAN. I've covered that also. The bandwidth, usually covers a small area such as a certain office, a few buildings, or perhaps a home. So unlike like WANs, LANs have no need for leased communication lines and tend to have this. It's more of your bandwidth. And also they mentioned the PRTG networking monitoring. We have covered that. You have covered that. You now understand the dynamics in terms of what needs to happen. What do you need in terms of your network? This we have covered. So it's an ideal situation in terms of reliable bandwidth management, to check whether what is happening in terms of your LAN network flow. Where are you being affected in terms of the slowness of your network? So most of the things that they mentioned we've covered in terms of the technical support project. So moving on to session 3, they explain further in terms of the WAN advantages and disadvantages we have covered, and the important terms in terms of the internet we have covered that, the email we have covered that, voice messages, it's your landline, we have that in your LAN networking. your e-commerce. This is more of your having maybe electronic commerce, like having an application within your system, and we install it in our server, and we want people to access that kind of application. That is more. And learn when hardware, it's your modems, we have covered that. uh, Most of the things we have covered, so it's more of you going through them. And you know, we have covered this in a simplest form, where you guys have a clue in terms of what is a LAN. So this is basically it in terms of uh 14913. So I would, the last item would be going through the questions, your assessments for formative and summative assessment. Okay, let's move on to the learner workbook, which is your formative assessment. Um Activity 1, describe the functions of the protocol. That's for 10 marks. Activity 2, distinguish between a LAN and a WAN. That's for 3 marks. Activity 3, demonstrate knowledge of the main features of LAN. That's for 5 marks. Activity 4, identify the main types of LAN media. That's for 5 marks. Activity 5, demonstrate understanding of the LAN bandwidth. That's for 5 marks. Activity 6, list disadvantages of the WAN. That's for 5 marks. Activity 7, explain the uses of hardware requirements for WAN. That's for 10 marks. Activity 8, explain explain what is internet, e-commerce, and mail. That's for 9 marks, so that's 3 each. And that's it in terms of your formative assessment. Moving on to your summative assessment. Activity 1, describe and explain the components of data communication system. That's for 7 marks. Identify the difference between a LAN and a WAN. That's for 4 marks. Activity 3, describe the main LAN configurations. That's for 5 marks. Describe and explain the advantages and disadvantages of a LAN. That's for 10 marks. Activity 3, demonstrate knowledge of main features of WAN. That's for 10 marks. Activity 6, identify the importance of using a WAN. That's for 5 marks. And that's it in terms of your summative assessment. So most of the things we have covered, you have done most of it. If you have managed to configure or went through the videos that I've shared, the previous videos, you would know uh, most of the things in terms of the configurations of the LAN and also of a WAN. The main features, it's much more easier if you went through the videos. So that's it in terms of this unit standard and the OSI model. I'll see you in the next video where we'll tackle through uh, configuring our LAN using a Cisco packet tracer. Thank you.